So now I want to talk a little bit about histograms, and just to clear up maybe a little bit of confusion that I might have seen on those. So histograms are a type of bar graph. Not every bar graph is a histogram, but a histogram is a type of bar graph, and particularly it's a frequency distribution. So our histogram is about one variable. It tells us about answers or measures or levels of a particular variable, not multiple variables, just one. And along the x-axis, we put all possible levels of the variable, right? And so I actually have one here where we see heights of black cherry trees. And the heights of the cherry trees can range from 60 to 90 feet. And you'll see we don't have every inch segment. The interval chosen by whoever made this is 5 feet, right? So between 60 feet and 65 feet, between 65 and 70 feet, between 70 feet and 75 feet, etc. That's the x-axis, all possible levels of our measures, right? So if we had a performance measure or a self-report measure that's 1 to 5, then it would be 1, 2, 3, 4, 5, etc. That's the x-axis. The y-axis is the frequency, how often a particular value occurs for that variable. So remember, a single variable, in this case, heights of cherry trees, right? That is one variable. And then the frequency among all different cases, so among all the trees that we looked at, the frequency that we got each of these heights. So again, along the x-axis, all possible values of a variable. Along the y-axis, the frequency at which each of those values occurs within our sample. Now, we can tell some things just by looking at our histogram, right? So we can get the mode from this. We can see that the mode is clearly between 75 and 80 feet. That tells us the mode. We can see that this is unimodal. We can get an idea of the symmetry. It appears to be more or less symmetric, right? Symmetry means that the left side and the right side look more or less the same. Our most important measure of symmetry is probably skewness, right? So skewness refers to where the tails are. So here I have another example of a histogram, and this one is about starting salaries. You might not be able to read it, but the shape is kind of more important. These are the gross monthly salaries. This is the frequency within those which those salaries occur in a particular organization. And you can see this is a highly skewed sample, right? So lots of outliers out here. And since that tail points to the right, we say that that's positively skewed. If the tail pointed to the left, we would say that it's negatively skewed, right? So it's all about where the tail points, about how something is skewed. So this is a very skewed. It's not symmetric. The right side and the left side don't look the same. And a lot of our statistics requires us to have symmetric distributions. And particularly the normal distribution is symmetric, right? So our normal distribution, and we see an example here of something that is pretty close to normal. Is it exactly normal? No, it's not exactly normal. Very rare to get a distribution that is exactly normal, but it is kind of close enough. Close enough is good enough. This is more or less a normal distribution. It's about as normal as you're going to get. You see it's unimodal. The mean and the median appear to be about the same and near the mode. We would guess that that's about right. It's not highly skewed. Yes, there's a little bit more to the left. You might start to make an argument about whether or not it's negatively skewed. And frankly, it's probably close enough. There are measures of skewness, right? So we say a skewness, as we measure it, we would say if it's below an absolute value of 1, then it's not skewed. If we have, and same thing with kurtosis, right? So this seems to be mesokurtic, which means kind of middle peakedness. Leptokurtic would mean a very high peak. Platykurtic is very flat, so our uniform distribution is platykurtic. This is what we call mesokurtic. So the normal distribution is one in which the mean, the mode, and the median are exactly the same. There is no skew, and it is a perfectly mesokurtic. And this is a close approximation of our normal distribution. So that's what we get from a histogram. So again, it's about one variable. That's really important. And then it's the frequency with which that variable occurs. The x-axis be all the possible levels of a variable, typically put in order of low to high, and then the frequency with which each one occurs. That gives us our y-axis. So that's just a little bit more about histograms and those frequency distributions. And I want to make one last point here before I finish up this video, probably not long enough for another video, just about your SPSS output. when you are loading up your SPSS output in the SPSS assignments. You have a couple of different options. Certainly, and many of you did this, you can save it. SPS gives you the option to save it as I think it's a .sav file, and that's fine. You are certainly welcome to copy it and paste it into your homework, right? And so that you could copy the output, the output that matters. You can copy it and just paste it into a document. Frankly, that's how I prefer it because it's very easy for me to look at on Blackboard that way. If you want to output the SAV file, that's fine too. I can just open up SPSS and look at it that way. My preference though would be if you can copy and paste it into the file. If that's impractical, SPSS also offers you the ability to export it into a doc or into a PDF file, and you can do that. And again, I would prefer that even over the SPSS file, but either one is fine.